Hey everyone, welcome back. So you have at this point learned all about triangle congruence, and we proved all of these or disproved them through rigid motion. So I'm here to kind of walk you through a summary of what we learned. So let's see. What I would suggest that you do is that you either have this document that I'm about to write on as a Cami assignment, right? Like you were able to click that link as to open it up into Cami, or you could have printed it out and you might be working on it on paper. So if you haven't already looked through this paper and tried it on your own, I would suggest that you do that. I would suggest that you stop the video right now, try it on your own, and then come back to me and we can go over it together. I think that's going to be much more valuable because this is not the first time you're learning it, right? Like this is a summary. We're going to put together everything you've learned and go over it together. So I would encourage, this really isn't new instruction. So please do that and then come back to me and we'll go over it. Amazing. So let's get started. I'm going to write my name. Miss Gallen. Right, and you're submitting this to us, so either you should be working through it on Cami, or you've printed it out and you're working it out on paper and you're going to upload it. Either one is fine. So I'm going to start by going through, and like our objective of this is to use triangle congruence criteria to identify if two triangles, right? And I'm going to emphasize that. I mean, I could prove three triangles congruent to each other, but I can't just have one. I need two triangles for this to work. So when I'm drawing a visual example down here, a single triangle is not going to show me that something's congruent, right? It's got to be congruent to something else. To identify if two triangles are congruent, write triangle congruence statements. Right? So think about how important notation and reason was for that. Oh, and explain my reasoning. Okay. So I don't like how I did this. I also don't like how I wrote my name. I want my handwriting to be slightly better for this. Miss Gallen. And then what did we say? Triangle congruence criteria. Two triangles. Triangle congruence statements. And explaining your reasoning. Explain. Okay, so we're going to go in order that we learned it in. Side, or SSS congruence. Did that prove that triangles are congruent, right? And maybe you remember in class, like you manipulated some sides. We gave you three sides and we said, hey, how many different triangles can you make? And you figured out, or we figured out as a class, that there was one unique triangle that could be created. It was just, they were reflections, rotations, or translations of one another, but they were congruent. There was only one triangle. So yes, this does prove congruence. If I wanted to draw a visual example, you know what? I'm going to get pretty creative here. I'm going to try to make this not challenging, but I want to use some of the things that I've learned. So hopefully you can see my two triangles. I'll label it A, B, C, and D. So I have a triangle right here, A, B, D, and I have a triangle right here, C, B, D. Right, I'm going to go ahead and mark this and this congruent and this congruent. Right, so I'm given two pieces of information. Right, so I'm given that CB is congruent to AB. I'm given that AD is congruent to CD. Right, so the other things that I know, right, that I don't need to be told are that BD is congruent to BD. And I'm going to write that is the, and maybe your picture is different and that's fine. Reflexive, property. And so that's congruent to itself. Therefore, triangle, maybe practice writing it, ABD is congruent to triangle. Well, if I write ABD, I control that. The second one's got to follow, triangle CBD. And your reason is by side congruence, right? So the congruent statements the reason, congruent statement, reason. These are the reasons triangles can be congruent. Sorry, these. Circling the wrong thing. Okay, I'm going to switch off colors. So what about side angle side congruence? Side angle side congruence is another one that, yes, it proved congruence, right? Like there was only one other way to connect those triangles. If I left those two sides the same and the angle that they formed, right? I couldn't move the dots. I couldn't manipulate them. We did this on a Google slide. There was only one triangle. There's only one third side that could be created. So let's draw an example of this. I'm going to get creative for some of them and then maybe not for all of them. And maybe your picture looks different. It's fine. S, T, A, B, R. Oh, goodness. So for side angle side, I'm going to know that this side and this side are congruent. This side and this side are congruent. Oh, wait, I only know two things. What's the third thing I know? Oh, maybe I know that angle SAT, angle SAT, is congruent to angle SAT RAB. How do I know that? They're vertical angles, right? That's like, you don't need to be told that. You got to look for it. It's just like the reflexive property. That then is enough information for me to conclude that triangle, make sure you do that symbol, right? I'm talking about something completely different. I can even use the letters in the same order. SAT is congruent to triangle. S corresponds with R. A corresponds with A, right? We need three letters here. We're not going to say angle A is congruent to angle A. You can say that up here. Can't say that down here because multiple angles have that vertex at A. SAT RAB by side angle side, right? It's two sides and the angle that is formed where they intersect. Okay. I lost the pen. There it is. All right. So let's keep going. Angle side angle. ASA congruent. So this is two angles and the side between them, right? It's the side that overlaps, the side that's included or shared, right? And this also proves congruence. I'm going to draw two separate triangles here as best I can. If you accidentally drew one triangle, make sure you're drawing a second one. M, A, P, R, Z, G. I'm just making up letters. I guess I'm not making them up. I'm just picking random letters. Okay, so two angles. Angle, let's say angle A and Z, I'll mark off the same. This one and this one, and then the side between them. It's going to be this side. All right, so I'm giving you all the information you possibly need there. It's two angles, and if I were to highlight the angle, which side am I highlighting twice? That's the side that is between or included, because it is angle, side, angle. Like the side is sandwiched between the two angles. So here I'm able to say, and be careful with this statement, triangle, let's say I say MAP is congruent to triangle. If I start with M, what corresponds with M? Oh, G. A, I'm then going to go to Z and then R. So make sure you're paying attention to those marks. By angle, side, angle. Right? That is not to be confused with this next one. I need some more colors though. Angle, angle, side, right? So this one is included. Oh, I didn't switch the color. This one is outside of those two angles. It is not the one between. So you know what? I'm actually going to draw something really similar because I probably can't replicate it perfectly. It'll be almost perfect. That's not even close. Let's see. T, M, L, J, P, Q. This angle, and this angle, this angle, and this angle. Well, if I'm doing a side that's outside of them, I don't want to mark the one that is included in both of them. I don't want to mark the one that I would highlight twice if I outlined the angle, right? That's wrong. I'm going to go with one. Let's say I went with this side. Oh, then I'm going with this side, right? So it's side, angle, angle. It is a side that is only on one of those angles. So this, I could then conclude that triangle, let's say I did TML, is congruent to triangle. And notice I'm never leaving off that symbol. I'm never leaving off notation. So you shouldn't either. T corresponds with Q. M corresponds with J. P by angle, angle, side. So really focus on the difference between this one and this one, right? It's a very similar idea to up here where it was side, angle, side. It is like sandwiched between there. You got to pay attention to where that part is. Like, yes, I have two angles and a side, but this side is not between them. So really focus. Don't just assume. And then we got to some of the stuff down here, and I might go a little bit out of order here because this one and this one go together, right? We talked about side angle, and you guys watched a video and engaged in conversations about this one, and side angle does not prove congruence, right? Or, right, like it can, right? It can if it's short side, no, long, short, angle, right? If it's big side, little side, and then the angle. But we said we would never write this. Like, this would not be an acceptable reason to prove triangles congruent because it doesn't, right? Like, it sometimes works, it sometimes doesn't. It's not a rule. Side angle does not prove congruence, right? So for instance, it was like that swing side, right? Like, it could create one triangle, it could create two, it could create none, right? We saw that happen. So if I'm going to draw a picture of this, I don't assume any angles, right? So this is, I'm just going to go with ABC. And then I'll go with X, Y, Z. Say I knew this, but I knew two sides. The angle is outside. The angle is not between like it was up there, all the way up there, right? So not in between. It is outside, is not where those two sides intersect. So we don't know this angle in here. So that's what happens. Like this side is called like the swing side. This is the ambiguous case. It's something, and I said this in the video you guys watched, I believe, but later on you will work again with something that is side angle. And it's referred to as the ambiguous case because we don't know. Like there's ways to figure it out, but we would need to investigate more to determine if one triangle is created, if two different triangles are created, or if literally no triangle is created, right? So I would here say not enough info. I'm not necessarily going to make that leap right now to say not congruent. If I knew something else, like if I knew that AC and XZ are not congruent, then yeah, I can say these are not congruent to each other. But with the information I've provided you here, we just don't know enough, right? And the time that we do know enough, this is the special case of big side, little side angle, right? Hypotenuse leg, you need to have a right triangle. This does prove congruence, right? This forces it to be long side, short side angle. big side, big side, little side angle. So just because something is a right triangle does not mean we're using HL, right? So you do need to look at it and look at it carefully. So if I have a right triangle, so I guess there's two things that need to fit. I need to have a right triangle and it needs to be side angle. So I should look at both pieces. So let's see, I've got this triangle and I've got this triangle. Right? I know my long side. I'll do the same thing. I'll do ABC. I know my long side is the hypotenuse. It's the side that's across from my 90-degree angle. I didn't need to put those 2 marks, actually. I only needed 1, right? We're not looking at the marks to determine how long something is. So I'll just go with 1. These are right angles. That makes it a right triangle. All right angles are congruent, right? I could pick either one. These are called the legs. Let's say I said BC was congruent to XZ. So all of this information is given. When I go around this, I've got 2 sides and a non-included angle. But because it is a right triangle, we would say that triangle ABC is congruent to triangle AB. What was A congruent to? Y. B is the right angle, so YXZ by HL. I am not going to say side angle. And again, like I could have said any of these other triangles up here were right triangles. Just because something is a right triangle, please avoid concluding that it must be HL. Like investigate everything. It has to be a right triangle and side angle. Therefore, you're going to write HL. Hypotenuse leg is what it stands for. Finally, I need one more color here. I might have already used a purple. It's okay. We have angle, right? And again, we found this one did not prove congruence, right? So this was a no also because we talked about the triangle sum theorem. And we said no matter how teeny tiny or how big it is, all the angles are going to add to 180. So if I know nothing about the sides, these two can't be congruent, right? Like the reason is, I mean, they might be, is a dilation could have happened. Did it dilate? I need to know more about the sides. So right now, if I said STBMLO, we would again say not enough info. Please don't go based off of how something is drawn. Like, or it cannot be determined. I would need to tell you something like ST is not congruent to ON. And therefore, like once you know one pair of sides, one pair of corresponding sides is not congruent, we can't make that conclusion. So here was a nice review of all of the criteria. So essentially, even if something's not multiple choice, you can make it multiple choice, right? If it says, are these triangles congruent and why, your reasons are either side, angle, side, angle, angle, side, HL, or these right here, these two, not enough info. Right? That's what, oh, sorry. That's just for this one and this one. Okay. So before we move on to some practice, I want to, and I talked about it a little bit up here, but what are some properties or assumptions? I don't love the word assumptions. We should always look for when proving triangles congruent. Let's see if we can name them. Vertical angles, that's a look for. Right? Vertical angles are always congruent. So it's like the tick marks, the things that are already marked off, it's like you walk into a crime scene and you see something. That's what the tick marks are. Like everyone sees it. We all know that it's true. Vertical angles are things that are true, but you might need to dig a little bit deeper to find them, right? Like you're not going to like walk into that room and know that it's there. Like you're going to have to look and make some conclusions based off of that information. Okay, so it's true, but it's not, you don't necessarily see it. It's like everyone knows it's true, but you don't see it. We also had along these same lines is reflexive property. if they share a side, it's congruent, right? So these two are things that everyone knows is true, but we don't necessarily see it. Some other things that you might have to make conclusions from are if you see that word bisect, right? If you have an angle bisector, then your cuts in half, right? That's what bisect means. So you have a piece of information, but you're going to have to draw a conclusion from it. Like you pick something up and you know that it leads to another thing, but you've got to kind of draw that conclusion. So that's what bisect is. Remember, if you bisect an angle, you get two congruent angles. If you bisect a segment, you get two congruent segments. So think about that. If you're cutting something in half, you get two parts of that. Two things that are congruent, two things that are half the length of the original. Another one that you might have to do with this is that word perpendicular. Sometimes you might see these together and you can draw even more conclusions. But perpendicular just means that it forms a right angle. So maybe you know that two segments are perpendicular to each other. So I know that those are two right angles. And I also know that all right angles are congruent, right? I'm going to actually write that. My goodness, this pen. Okay, that's another good one. So think through those things. And the more you work with this, the more you think about this, the more as we progress through this course and we start looking at things like formally writing out our thoughts and proving things, this will help, right? So we're really building your capacity with this. Okay, so let's do some practice. And what I would really encourage you to do is to stop the video and try these, right? Try them before you listen to me talk through them. I know I'm exciting, but you might want to try it on your own first. So number one, so I'm given actually three pieces of information. I'm given AB. I like to write it out. I don't know if I'm going to do this for every single one, but I think it's a good habit to get into. AB is congruent to XY. What else do I know? AC is congruent to XZ. And I'm given, and I can use one letter for this, angle A is congruent to angle X. So I have two sides and the angle between them. Two sides and the angle where they intersect. So I'm able to, and this is really the key part here, say that triangle ABC is congruent to triangle, well, A corresponds with X, B corresponds with Y, X, Y, Z, by side angle side. Right, so this is not a requirement. This is just helping for where we're going. Right, but think about why they're congruent before you even write that statement. If you said BAC, you would have ended up with YXZ. Awesome. Okay, so let's see. Are these two? So I've got two angles and a side that's not between them. So angle, angle, side. Angle, angle. Oh, that proves congruence, right? So I can say from this, the triangle A, you know what, I'll go with ACB. It's congruent. I control that. So do you. ACB is congruent to A corresponds with X, C corresponds with Z, Y by angle, angle, side. Two angles and a side that's not between them. If you say side, angle, angle, you're fine. You got it. If you said BAC, you would have said YXZ, right? So if I rearrange one of them, the other one's going to have to follow. What about this one? I've got angle, angle, angle. Does that prove congruence? Right? So what are we going to say here? Not enough info. Cannot be determined, right? Angle, angle does not, prove congruent. So it's like inconclusive. What about 4? So here I've got side, side, right? A side and a side, and then an angle that's not between them. Oh boy, so I've got side, side, angle. Oh no, that doesn't prove congruence. But I have a right triangle. Look at that. So what should I say? HL, right? Hypotenuse, leg. That only works for a right triangle. So I had side, side angle, and it was a right triangle. So I can say triangle ABC is congruent to triangle A corresponds with X, B corresponds with Y, Z by HL, right? Notice I didn't write side, side angle. I crossed that out. We don't like that word. What about here? BA and XY are congruent. BC and YZ. And then we have a third side. So we've got three sides of one triangle are congruent to their corresponding sides on another triangle. So I'm able to say that triangle, let's say I said CAB, is congruent to triangle, be careful here sometimes. So it's between 2 and 1. 2 and 1. So Z, A is between 1 and 3. ZXY by side, side, side. Ooh, what about this next one? I only see two things, GH and OH, and then HU and HL. Do you know anything else? Of course you do. What about these? Let's write it out. Angle. I'm not going to say H. I'm going to say GHL. Angle. I'm not talking about the triangles yet. Is congruent to angle GHL OHU. Right? They're vertical angles. I'm not done. I haven't proven the triangle's congruent. I'm just saying, how did I mark that off? How did I know that? Right? They're congruent because they're vertical angles. Therefore, triangle GHL is congruent to triangle. And notice I just changed that symbol and I'm talking about something different. GHL is congruent to OHU by side angle side. It is two sides and the angle that's between them. And notice I'm figuring that out by just looking at one triangle. I'm not looking at like side, angle, side. You're not skipping to another triangle. I need three pieces of information on a single triangle. What about 7? We've got a few more to finish up here. 7. So I've got side, angle, side. Oh, so side, angle, side. Wait a minute. I have this, but then I have side, side. It's not congruent to the right thing. So something's not right. Right? Like this is side, side, angle, and this is side, angle, side. I've got to really look at it closely. This, I need to know more. I need to know, is BC and XY congruent to each other? Right? Like I need a little more information. So let's see. Not enough info. There's none. I need more. What about this one right here? BW bisects an angle. Oh, bisect. That means cut in half. EBS. I'm cutting this angle in half. Well, if I do that, I get these two angles are congruent, right? This allows me to say that angle EBW is congruent to angle SBW, right? That's the definition of bisect. I also know BW is congruent to BW, right? That's what we know as the reflexive property. So think through the things that you know, right? Like I can now mark that off. So now if I look, I have two sides, and the angle that's between them. Again, I'm not jumping from one triangle to another. I should be able to break these apart and still be able to mark it and talk about them. I have three pieces of information on each triangle. 3 parts of one triangle are congruent to 3 parts that correspond to those on another triangle. Therefore, I can say triangle EBW is congruent to triangle SBW by side, angle, side. And again, I'm not saying side, angle, side. I am doing side, angle, side. You need to be able to break these apart. That can get tricky. Okay, let's finish up with these last two. So let's see, I've got side, angle, side. Oh no! Oh no, this side is congruent to this side. We actually know that these aren't congruent because these two sides, if they have a right angle, these two can't be congruent, right? So you can say not enough information, but these are actually not congruent. You can write it out and say triangle ABC is not congruent. You can draw this congruent symbol with a line through it if you wanted. ABC, X, I don't even know what to go with that. It doesn't even matter. X, Y, Z, I guess I'll go with. We actually know that they're not because if this side, if AB is congruent to the hypotenuse over here, that definition of a hypotenuse is that it's the longest side. So this one, BC, is going to be longer than ZY. Like it has to be. And I know that because you've got a right triangle, but these are not congruent. If you say not enough information, that's fine because that's what we've been working with y'all. And finally, this one right here has got two angles and a side between it. It is included, and I'm looking at both triangles. So I can say triangle BCA is congruent to triangle B is Y, C is Z, X by angle side angle. All right. So hopefully what I'm hoping happened is that you guys had already tried this and this was your opportunity to go over it with me. If you've got questions, bring them to class, write them down, ask us, and we will happily answer. If you need to go back and rewatch any of this, awesome. You are submitting this paper to us. So whether you're submitting it through Kami, which you can click share document and make sure that you have changed it. I would just give everyone edit access, right? Or you can change it to anyone with the link is a viewer and editor, because if you don't have that, then we won't be able to see it. You might need to check your drive settings. So just make sure that you're giving us access to be able to see this document. Otherwise, you could also download it if you wanted. You can download it to a PDF and submit it that way. That works as well. That might be a better way of doing it so that we're able to see it and comment and provide you the necessary feedback. So thanks everyone for watching, and I will see you next time.